All right, today we're putting on our detective hats to solve a pretty fascinating statistical mystery. We're going to be hunting for a hidden culprit, one that can sneak into our data and lead us to completely wrong conclusions. So let's grab our magnifying glass and get right to it.
Our case starts with a really simple question, one that gets asked in boardrooms all the time. If a company invests in being, a good company, socially, environmentally responsible, does that actually help its bottom line? It feels like it should, right? But in the world of statistics, what feels right isn't always the whole story.
And here it is. This is our case file. We've got data on a bunch of different companies. And for each one, we have two key pieces of evidence. First, their ESG score. That's our measure of goodness. We'll call it X. And second, their firm value, the outcome we really care about, which we'll call Y. Our mission, should we choose to accept it, is to figure out the real relationship between the two.
Now, you'd think, okay, straightforward question, let's get a straightforward answer. So for our first move, let's start our investigation with the most common tool in any statistician's toolkit.
We're going to start with a standard technique called ordinary least squares, or OLS for short. All you need to know is that it's basically like drawing the best possible straight line through all our data points to spot the trend. Now that formula it spits out, it gives us one really crucial number, 0.76. That's our first clue, the coefficient that seems to describe the link between a company's goodness and its value.
So, what's this number telling us? Well, it suggests that for every single point a company's ESG score goes up, its value climbs by 0.76 units. Pretty neat, huh? Case closed. Good companies are more valuable. But, not so fast. Any good detective knows you always question your evidence. And that brings us to the big plot twist in our little detective story. There's a hidden problem that could be lurking in our data, making that simple answer, well, just plain wrong. What if that key variable we're relying on, that ESG score, what if it's tainted? What if it's not telling us the whole unbiased truth? In statistics, that's a massive, massive problem.
And this problem has a name, endogeneity. This right here is the villain of our story. It's a bit of a technical term, but just think of it like this. Our main clue, X, is secretly connected to other stuff that we can't see. And that secret connection is totally messing with the real link to Y that we're trying so hard to uncover.
So where does this corruption come from? Well, it can sneak in from a couple of places. First, maybe there's a missing variable. Like, what if really talented managers are the real reason for both a high ESG score and a high firm value? If that's true, we're giving all the credit to the wrong suspect. Or, second, what about reverse causality? Maybe being good doesn't make a company valuable. Maybe being valuable is what gives a company the extra cash to spend on looking good. See the problem? Either way, our simple analysis is totally compromised.
Now, when your main piece of evidence is tainted, you don't just throw up your hands and go home. Nope. You find a special tool, a secret weapon, if you will, to clean things up and get to the truth.
And for us, that special tool is called an instrumental variable. It's a more advanced technique that lets us cleverly work around this whole endogeneity mess.
So what makes this tool so special? Well, it has to follow two very, very strict rules. First, it has to be a great predictor of our corrupted evidence, that ESG score. And second, and this is the tricky part, it can't have any direct connection to our final outcome, firm value, except for the influence it has through the ESG score. It's kind of like finding a witness who we know influenced the suspect, but had absolutely nothing to do with the crime itself.
And for our case, we've found our instrument. It's a variable called the Industry Regulation Score, and we'll call it Z. The logic here is pretty solid. Tougher industry regulations are going to push a company to improve its ESG score, right? But those regulations themselves don't just magically make the firm more valuable. It fits our criteria perfectly.
Okay, so we have our secret weapon. Now it's time to actually use it. This is a two-part process, a two-stage investigation designed to clean up our evidence and find the real answer.
We call this the two-stage least squares investigation, or 2SLS. It's simple, really. Step 1, we use our clean instrument Z to create a predicted, untainted version of our ESG score. We'll call this new guy X hat. Then, in step 2, we take that clean X hat and use it to find the true relationship with firm value. So, let's break that down.
In stage 1, we're basically isolating the part of the ESG score that's driven only by our clean instrument, that regulation score. Think of it like running our original ESG score through a filter. We're running a regression, but instead of predicting firm value, we're predicting the ESG score, X, using only our trusted instrument, Z. This whole process filters out all that junk, all those hidden, corrupting factors. And voila! Here's what comes out on the other side. On the left, you've got our clean instrument, Z, and on the right, you have the brand new squeaky clean values for our ESG score, X hat, that our stage 1 model predicted for us. This is our decontaminated evidence, and it's ready for the main event. And now for stage 2. We go back to our original question, but this time we swap out the potentially corrupted evidence, X, for our shiny new clean version, X hat. And would you look at that? The relationship has changed. Our new coefficient is 0.90. This is our second and supposedly much more accurate answer.
So now what? We have 2 different results from 2 different methods. One was simple, the other was a lot more complex. Which one is telling the truth? It's time for the final verdict. And here it is, the heart of our dilemma. Our first, simple investigation said the effect was 0.76. Our more advanced, 2-stage investigation says it's 0.90. That's a pretty noticeable difference, right? So was our initial suspicion correct? Was our data corrupted all along? To settle this once and for all, we need an impartial judge. In statistics, that judge is a procedure called the Hausman test. Its one and only job is to look at our 2 answers and tell us if the difference between them is actually big enough to matter or if it could just be random chance. It's literally testing if our villain, Endogeniety, was ever really at the scene of the crime. The test runs all the numbers, does its calculations, and it delivers a single piece of evidence, the test statistic. And in our case, that number is 0.653.
But of course, that number doesn't mean anything by itself. It needs to be compared against a threshold, a legal bar for proving guilt. That's the critical value. To prove that endogeniety was a real problem, to find it guilty, our test statistic needed to be higher than this value, 3.84. And here it is, the final and honestly pretty surprising verdict. Our statistic, 0.653, is way smaller than the critical value of 3.48. So, in courtroom terms, we just don't have enough evidence to convict our data of being corrupted. After all that advanced detective work, it turns out our first simple answer was probably just fine all along.
And this whole case leaves us with a really fascinating final thought. We had this strong theory, a real suspicion, that our data was flawed. But in the end, the evidence just didn't back it up. It's a great reminder that in any investigation, whether it's in a detective story or data analysis, it's just as important to test our assumptions and be ready to prove ourselves wrong. Thanks for joining the investigation.